So how does the production function affect the shape of the cost curve? Well, the cost curve really depends on two things, the production function and the price of the inputs. So if your only variable cost is labor, and you use L units of to produce Q units of output, then your variable cost to produce Q units of output is just going to be the wage times the amount of labor you use. So it's W times L, where W is the wage rate, L is the amount of labor you need to produce Q units of output. Let's suppose your production function is F of LK, but your capital is fixed in the short run at K bar. So your short run production function is going to be F of L K bar, and the only thing you can vary is L. Let's represent that by G. So G of L is just F of L with capital level K bar. So your short run production function only depends on your labor input, and it's G of L. So if you use L units of labor, your output is G of L. So L units of labor are going to produce G of L units of output. If you are familiar with the idea of an inverse of a function, this just says, it gives you the reverse relationship. L units of labor give you G of L units of output. And so if you want the reverse relationship, you're going to use the inverse function. As an example, suppose you had G of L was some number A times L. So if you use L units of input of labor, you get A times L quantity as output. So if you wanted to know what G inverse of Q was, well, it would just be Q divided by A. Why is that? It's because, let's suppose I want to produce Q units of output. How many units of input do I need to use? If I use Q over A units of input, and I feed that into my production function, then I get A times Q over A. The A's cancel, so I get Q units of output. So what is the L that I need in order to get Q units of output? That's what the inverse function tells us. So the variable cost is just, to produce Q units, is how much labor do I need to produce Q units, which is the inverse of G, times the wage rate for labor. So it's W times G inverse of Q. What we can do now is to derive the marginal cost and the average variable cost from this function G. So the marginal cost, remember, is the derivative of the variable cost with respect to Q. Now, variable cost on the previous slide we just discussed is wage times the inverse of Q. Now, it turns out if you want to know the derivative of the inverse, it's just 1 over the derivative of G. So this is wage, so dWg inverse of Q with respect to Q. Well, W is a constant, so it's W times d G inverse of Q dQ. So it's a derivative of the inverse function with respect to Q. Now it turns out there's a standard result in calculus that says that the derivative of the inverse is just 1 over the derivative of the original function. So the derivative of the inverse of G is just 1 over the derivative of G, which is this. But we know what this thing is. The derivative of the production function is just a marginal product. So the marginal cost is just W times 1 over marginal product. In other words, it's W divided by marginal product. Now this, if you think about the units that these things are measured in, this equation makes perfect sense. Marginal cost is dollars per unit. The wage is going to be measured in dollars per hour of labor. And marginal product is units, the additional units you get per hour of labor. So if we take the ratio of those two, the hours cancel out, so we get dollars per unit, which is the same as what marginal cost is measured in. Now, if we have a diminishing marginal product of labor, what that says is that eventually, as you keep increasing labor, the marginal product is eventually going to decrease. That corresponds to the marginal cost eventually increasing because the marginal product is the denominator. Wage, of course, is going to be a constant. So as marginal product decreases, marginal cost is going to increase, which makes perfect sense. If every additional unit of labor is less productive, then your marginal cost is getting higher. You need more labor to produce an additional unit of output. We can look at the average cost in a very similar way. Remember, average cost is variable cost divided by quantity. Now, variable cost is just W times the quantity of labor needed to produce Q units divided by Q. Quantity of labor unit needed to produce Q units is just G inverse of Q. What we can do now is to divide both numerator and denominator by G inverse of Q, so we get wage, the G inverse of Q cancels, divided by Q divided by G inverse of Q. But remember, G inverse of Q is the amount of labor that you're using. So it's just L. So we have W divided by Q over L. But what's Q over L? Q over L is the quantity that you produce divided by the labor that you're using. That's nothing but the average product of labor. So we then have that average cost is wage divided by average product of labor. So it's a very analogous relationship between average cost and average product that we saw between marginal cost and marginal product. Again, what we saw is average product is going to rise and then fall. So what that means is that average cost is going to fall, then rise. As this goes up, this goes down. On the other hand, if this goes down, this goes up.